In this video we'll be talking about electron arrangement, so how electrons are arranged inside of an atom. Before getting into this topic though, you need to know how to find out the number of electrons. So all of the elements are listed in the periodic table, and in each of those boxes you're given information about those elements. You can use those numbers to find out the number of electrons. So let's look at sodium in more detail. Sodium has two numbers just like any other of those elements. There is a bigger number and a smaller number. The bigger number is the mass number. This is the number of protons and neutrons altogether. And the smaller number is the atomic number. This is the number of protons the atom has. So sodium has 11 protons. The number of protons is always equal to the number of electrons. And that's how we find out the number of electrons using the periodic table. Now when drawing the electron arrangement of atoms, you need to know the structure of an atom. We have the nucleus in the center where the protons and neutrons are located, and then we have electrons in fixed energy levels or shells, and these electrons orbit the nucleus. Now you know the structure of an atom. Let's go through the rules for drawing electron arrangement. The shell closest to the nucleus fills up first, so this is the shell closest to the nucleus, the inner shell. The first shell, so the shell closest to the nucleus, can only hold up to a maximum of 2 electrons, no more. The second shell can hold up to 8 electrons, and so do the following. So the second and the ones after it can all hold up to 8 electrons each. And the outer shell has the highest energy level. So the inner shell has the least energy, and the outermost shell has the highest energy. So let's have a go at drawing the electron arrangement for sodium. Remember we said sodium has 11 electrons. So we have the nucleus in the center. In the first shell we have 2 electrons because that's how much it can hold up. In the second shell we have 8 electrons. So far we have a total of 10 electrons, but remember we need 11 electrons. Now the final 11th electron cannot fit in this shell because we can only have 8 electrons. So we need to draw another shell to place the final electron in there. So this is the electron arrangement of sodium. Now the electron arrangement can also be written in terms of numbers rather than rings like we've done here. And to do that you simply write the number of electrons in each shell. So we have 2 electrons in the first shell, 8 in the second, and 1 in the final. And each of these numbers are separated by a comma. Let's have a go at another example. This time let's do the electron configuration for fluorine. Fluorine has a mass number of 19, which is the number of protons and neutrons together, and it's got an atomic number, which is the proton number, of 9. And remember we said the proton number is always equal to the electron number, so fluorine also has 9 electrons. Now we know the number of electrons, let's do the electron configuration. We have the nucleus in the center. We have 2 electrons in the first shell, we can't fit in anymore because remember the first shell can only have 2 electrons. Now the remaining 7 electrons are placed in the second shell. Remember the second shell can hold up to a maximum of 8 electrons, but we only need to put in 7 to give us a total of 9. And we can also write the electron configuration or the electron arrangement in terms of numbers. This would be 2, 7. 2 in the first shell and 7 in the second shell. Here are a few examples for you to try. Use the periodic table to determine the electron arrangement for calcium, neon, and oxygen. For each of these elements, draw the electron arrangement in terms of those rings with the diagram and also in terms of numbers.